Good morning. I am Divyajyoti, lecturer in computer engineering from Pandit J.R. Government Polytechnic College, Hoshiarpur. Today we are going to learn about internet connectivity. Internet connectivity is the means by which individual terminals, computers, mobile devices, and local area networks are connected to the global internet. Internet access is usually sold by internet service providers that use many different technologies, offering a wide range of data rates to the end user. And first, internet access became popular through dial-up connections in the early 1980s and 90s. By the first decade of the 21st century, many consumers had switched away from dial-up to dedicated connections. At that time, most internet access products were being marketed using the term broadband. Internet access technologies generally use a modem which converts digital data to analog for transmission over analog networks such as telephone networks and cable networks. So this particular diagram shows the basic function of modem. At the sender end modem, the function of modem is to convert the digital data coming from your computer into the analog signal so that it can travel over the analog network. And on the receiving end, the function of modem is to convert the analog signal into the digital data so that it can be presented on your computer screen. Most internet access today is through a LAN, often a very small LAN with just one or two devices attached. In a limited area such as a home, school, or computer laboratory or office building, local area networks, which are called LANs, they provide internet access to computers and other devices, usually at relatively high data rates that typically range from 10 to 1000 Mbps. There are wired and wireless LANs. Ethernet over twisted pair cabling is the most common technology, wired technology. Wi-Fi is the most commonly used technology, which is a wireless LAN. While LANs are an important form of internet access, there are various ways by which these LANs can be connected to the global internet. The selection of internet connection mainly depends upon our requirements, means how fast and how often we need to transfer data. And second thing is the options available in that particular geographical area. While discussing internet connectivity, we come into contact with two terms, upstream and downstream, or uploading and downloading. What these terms mean actually: upstream or uploading refers to the data traveling from a subscriber customer to an ISP, whereas downstream or downloading refers to the data traveling from an ISP in the internet to a subscriber or user. So this diagram shows or explain the terms downstream, where data is traveling from the internet service provider to the subscriber's location, and in the upstream the data is traveling from the subscriber's location to the internet service provider. Internet connectivity technologies can be broadly classified into narrowband and broadband. These two categories are based upon the data rates they provide. First of all, let's discuss what are narrowband technologies. They refer to technologies that deliver data at up to 128 kilobits per second. Some narrowband technologies are listed here, like dial-up connections, leaf circuit, ISDN. Broadband technologies generally refer to technologies that offer high data rates than narrowband technologies. In telecommunications, broadband refers to a communication bandwidth of at least 256 kilobits per second. Various broadband technologies include DSL, cable modem, wireless access technologies. If we compare these two technologies, we come with some points that describe these technologies more. First is service area. For both narrowband and broadband technologies is national, it may be regional or local. Example or most commonly used technology under narrowband is dial-up, and under broadband is DSL, cable, satellite or wireless access. Speed in case of narrowband is very slow, under 56 kbps, and in broadband it provides fast download speeds but somehow slower upload speeds. Features in narrowband and broadband are same, like email, personal web pages, instant messaging. Equipment which is used for narrowband, that may include a PC or computer, a phone line, and a modem. For broadband, it may include PC, phone line, cable, and in addition to this, it may be through satellite dish, or it may need DSL modem, cable modem. Security: in case of broadband, user must check to see if firewall is installed. And for narrowband, there is unlimited or set amount number of minutes, and in broadband this is always on connection. In case of narrowband, the cost is very much less in comparison to the broadband technologies. So now we are going to discuss about the various internet connections, like dial-up connection, which is a narrowband connection, broadband connection, leased line connectivity, ISDN, VSAT, RF link. First of all is dial-up connection. This diagram explains this connection. So you can see here that the dial-up internet connection is a connection type that operates through a standard telephone line. Your computer is connected to the modem, and modem is then connected to the phone line, your traditional phone line, which is further connected to the internet service provider and then to the internet backbone. It uses the facilities of the public switched telephone network, which is called PSTN, to establish a dialed connection to an ISP via telephone lines. The user's computer or router uses an attached modem to encode and decode internet protocol packets and control information into and from analog audio frequency signals respectively. How dial-up connection works: dial-up process uses a modem and a phone call placed over the public switch telephone network to connect to a pool of modems operated by an ISP. So this diagram shows the working of, or the how the dial-up connection is set up. Your PC is connected to the dial-up modem, which is further connected to your telephone, and through the telephone wires it is connected to the telephone exchange, which is further connected to the ISP. By attaching the telephone line to a computer through a modem and configuring the computer to dial a specific phone number, the computer is granted internet access by the ISP. That is why it is called dial-up connection. Typically, dial-up connections do not exceed a speed of 56 kbps, as they are primarily made using modems that operate at a maximum data rate of 56 kbps downstream and 34 to 48 kbps upstream. The actual downloading rate fluctuates with the quality of your telephone connection to the telephone company's center office, and usually it averages at or below 50 kbps. So the various types of dial-up modems which are used are internal modems and external modems. Internal modems, they fit into a free slot inside the computer. That is why they are called internal, because they reside inside your CPU case. Users have to simply install the drivers for it and attach the telephone wire to it. You can see the how internal modem look like. External modems, they connect to the computer with a cable. That means they are placed external to the CPU case. A telephone line is plugged into the modem to connect it to the phone system. Advantages of dial-up connection: it is usually inexpensive. Dial-up access may also be an alternative for users who have limited budget for accessing the internet. Since dial-up connections require no infrastructure other than the telephone network, therefore dial-up remains useful where telephone access is widely available. It is often the only choice available for some rural or remote areas where other internet access technologies like broadband installations are not prevalent due to low population density or due to high infrastructure cost. Disadvantages of a dial-up connection are: first one is operating on a single channel. A dial-up connection monopolizes the phone line. It means while connected to the internet, you will not be able to make or receive phone calls. That means it tie up your phone line. While accessing internet, you are not able to make or receive any phone calls, and when you are making or receiving a phone call, you are not able to connect to the internet, because the same telephone wire is used to connect to the internet. It is one of the slowest methods of accessing the internet and may not be adequate for users who use the web for multimedia and other high bandwidth applications. That means if you want to download files with a large size, then this may not be the adequate method of internet access. Next is broadband connection. This term broadband refers to the wide bandwidth characteristics of a transmission medium and its ability to transport multiple signals and traffic types simultaneously. The medium can be a coaxial cable, it may be a fiber, optical fiber, it may be twisted pair, or the medium may be wireless. In contrast to broadband is the term baseband, which describes a communication system in which information is transported across a single channel. In telecommunications, broadband refers to a communication bandwidth of at least 256 kbps. Broadband technologies supply considerably high bit rates than dial-up, generally without disrupting your regular telephone use. Typically, they offer speeds from 700 kilobits per second or higher, for two-thirds more than the price of dial-up on average. Wired broadband connections offer with speed of up to 100 megabits per second. Most broadband services provide a continuous always on connection. That means there is no dial up process required, and it does not make phone lines unavailable while accessing the internet. So broadband provides improved access over the dial up to internet services such as faster worldwide web browsing, faster downloading of documents, photographs, videos, and other large files, telephony, radio, television, and video conferencing, virtual private networks, and remote system administration, online gaming. So, these all are the services which are provided by broadband in a better way. There are a variety of broadband technologies which are used today. One of them is DSL, cable internet access, optical fiber, Wi-Fi networks, which are used in the areas which are not served by ADSL or cable. Wireless and satellite internet, it is often used in rural, undeveloped, or other hard to serve areas where wired internet is not readily available. Newer technologies being deployed for fixed and mobile broadband access include WiMAX, HSPA, HSPA Plus. Mobile broadband access allows smartphones and other digital devices to connect to the internet from any location from which a mobile phone call can be made or subject to the capabilities of that mobile network. So first of all, the first broadband technology we are going to discuss is DSL, digital subscriber line. It provides a broadband connection to the internet by transmitting digital data over the wires of a local telephone network. Unlike dial-up, DSL can operate using a single phone line without preventing normal use of the telephone line for voice phone calls. It uses high frequencies while the low frequencies of the line are left free for regular telephone communication. These frequency bands are subsequently separated by the filters which are installed at the customer's premises. DSL technology provides high-speed broadband network connections to homes and small businesses. It only works over a limited physical distance, and it is frequently referred to as always on connection. With an always on connection, customers no longer need to physically dial up to the internet service provider to log into the internet. A few access providers now offer DSL service implemented with point-to-point protocol over internet that does not support always on, but in this case a DSL router can automate the connection process. The data rate of DSL services typically ranges from 256 kbps to 20 mbps downstream, depending on the DSL technology, line conditions, and service level implementation. Typical setup of a DSL technology consists of, on the customer side, a DSL modem is hooked up to a phone line. The telephone company connects the other end of the telephone line to a DSLAM, which is called digital subscriber line access multiplexer, which combines a large number of individual DSL connections into a single box. The location of the DSLAM depends on the telecommunication or telephone company, but it cannot be located too far from the user because of attenuation, otherwise the quality of the service will be poor. When the DSL modem powers up, it goes through a sync procedure, which is called synchronization procedure. The actual process varies from modem to modem, but generally involves the following common steps. First is the DSL modem performs a self test, during which it checks the connection between the DSL modem and the computer. You must have seen that for residential variations of DSL, the connector is usually Ethernet port or a USB port. In rare models, it may be a Firewire port. Also, some variations of DSL, such as SDSL, use synchronous serial connections. The DSL modem then attempts to synchronize with the DSLAM. Data can only come into the computer when the DSLAM and the modem are synchronized. You must have seen on the external modems which are installed in home commonly, there is a indicator labeled DSL or link on the external modem, which can be used to tell if the modem is synchronized or not. During synchronization, the light flashes. When synchronized, the light stays lit, usually with a green color. So this indicator shows whether your modem is synchronized with the DSLAM or not. This particular diagram shows the typical setup of a DSL technology. Now here you can see that modem and router can be combined. That means mostly today ISPs provide you a modem with a wireless router through which you can connect your mobile devices like laptop. On the other end is the telco central telephone company's central office, where DSLAM is located. Various types of DSL technology are available, and these are collectively referred to as XDSL. They can be the types of DSL technology can be broadly classified as symmetric and asymmetric. Symmetric DSL provides identical data rates upstream and downstream. That means it provides equal bandwidth for both uploads and downloads. That is why it is called symmetric. Symmetric DSL technology is popular for business class DSL services, as companies often have greater needs for transferring data. Typical symmetric DSL connections support 1.5 Mbps for downloads and uploads. Common forms of symmetric DSL include SDSL, HDSL, SHDSL. SDSL stands for Symmetric Digital Subscriber Line, that is single line DSL. Originally it was developed in Europe. SDSL was one of the earliest forms of DSL to not require multiple telephone lines. That is why it is called single line DSL. SDSL supports data rates up to 3 Mbps. It requires a special SDSL modem. Next is HDSL, which is called high data rate DSL or high speed DSL. HDSL technology was developed in the early 90s, making it one of the oldest forms of DSL. It offers data rates up to 2 Mbps and requires multiple phone lines to accomplish this. Next is SHDSL, which stands for Symmetric High Bitrate Digital Subscriber Line. It can transport data symmetrically at data rates from 192 kilobits per second to 2320 kilobits per second. SHDSL utilizes a single copper wire pair, making it an affordable DSL option attractive to small businesses. Next is asymmetric DSL. The most commonly installed variety of DSL is asymmetric. Asymmetric DSL provides relatively lower rates upstream but higher rates downstream. That means more network bandwidth is provided for downloading than for uploading. It is mainly popular in residential DSL services as home internet users predominantly use downstream bandwidth. Typical asymmetric DSL services support 5 Mbps for downloads and 1 Mbps for uploads. Common forms of asymmetric DSL include ADSL, RADSL, and VDSL. ADSL is asymmetric digital subscriber line. It is designed to support the typical home user who frequently downloads large amounts of data but uploads relatively less often. ADSL works by allocating a majority of the available phone line frequencies for communication of downstream traffic. It requires a special ADSL modem. ADSL is technically capable of up to 6 Mbps, but ADSL customers in practice obtain 2 Mbps or lower for downloads and up to 512 kbps for uploads. RADSL stands for Rate Adaptive Asymmetric Digital Subscriber Line. Rate adaptive means it is an implementation of ADSL that automatically adjusts the connection speed to adjust for the quality of the telephone line. This feature allows the RADSL service to function over longer distances than does ordinary ADSL. In RADSL, the broadband modem is configured at startup to test the phone line and adjust the data rate. RADSL typically operates at a lower rate than regular ADSL. VDSL stands for Very High Bitrate Digital Subscriber Line. It is a DSL standard which was approved in 2001. It can achieve data rates up to approximately 52 megabits per second, making it the fastest available form of DSL. To perform at this speed, VDSL relies on fiber optic cabling. It offers fast data rates over relatively short distances because short distance means fast bit rate. So after discussing about this DSL technologies, we now discuss about the advantages of DSL over other technologies like dial-up and narrowband technologies. You can leave your internet connection open and still use the phone line for voice calls, which is not possible in case of dial-up connections. The speed is much higher than a regular modem or than a dial-up modem. DSL doesn't necessarily require new wiring. It can use the phone line you already have. The company that offers DSL will usually provide the modem as part of the installation. Even if the company doesn't provide, you can buy your own. Disadvantages of DSL: a DSL connection works better when you are closer to the provider's central office. The farther away you get from the office, the weaker the signal becomes. The service is not available everywhere, like in rural or remote areas, the service is not available. Cable internet access: this is the other technology which provide internet technology which provide you broadband connection, often shortened to cable internet or simply cable. It is a form of broadband internet access that uses the cable television infrastructure. Like in case of DSL, we uses the existing telephone network. In case of cable internet, we use the existing cable television infrastructure to provide the internet access. Like DSL, broadband cable provides a continuous connection with an ISP. Cable internet speeds range from 512 kbps to 20 Mbps. Broadband cable access tends to service fewer business customers because existing television cable networks, they tend to service residential buildings, and commercial buildings do not always include the wiring for coaxial cable networks. Downstream bit rates can be as much for 100 Mbps for business connections and 100 Mbps for residential services in some countries, and upstream bit rate ranges from 384 kbps to more than 20 Mbps. Typical setup of a cable internet access technology. For broadband cable internet access, you require a cable modem at the customer's premises and a CMTS, which is cable modem termination system, at a cable operator facility, or you can say your cable operator's main office, which is called head end of that cable operator. Then these two are cable modem and CMTS. They are connected via coaxial cable or a hybrid fiber coaxial cable plant. This particular diagram shows the typical setup for the cable connection, cable internet access. At the one side is the subscriber's premises, on the other hand is the cable head end, which is the main central office of the cable operator. The cable connection which is coming from the cable operator, that is connected to the splitter. One wire from the splitter goes to your cable modem and the other goes to the set top box of your TV. The cable modem is then further connected to your computer through some Ethernet port, and the signals coming from the splitter from your the subscriber's premises and from the satellite dish, they are combined together and fed into the CMTS, which is further connected to the internet service provider. A cable modem is a type of network bridge and modem that provides bidirectional data communication via radio frequency channels on a hybrid fiber coaxial infrastructure, HFC infrastructure. In a cable modem termination system, all nodes for cable subscribers in a neighborhood connect to a cable company's central office, which is known as the head end, which you have seen in the previous diagram. The cable company then connects to the internet using a variety of means, usually fiber optic cable or digital satellite and microwave transmissions. Hybrid fiber coaxial, that is HFC, is a broadband network which combines optical fiber and coaxial cables. It has been commonly employed globally by cable television operators since the early 90s to carry television signals. By using frequency division multiplexing, HFC network may carry a variety of services including analog TV, digital TV, video on demand, telephony and high speed data. Cable internet systems can typically operate where the distance between the modem and the termination system is up to 160 kilometers. If HFC network is large, then the cable modem termination system CMTS can be grouped into hubs for efficient management. So advantages of cable internet access are: cable modem download speeds are typically up to 2 times faster than DSL technology. However, cable technology is based on shared bandwidth with which the speed fluctuates depending upon the number of subscribers on the net. With DSL, the connection is yours and not shared, and you tend to have a more constant speed. But still, the speed of cable modem is faster than the DSL modems. It may fluctuate depending upon the users or the subscribers on the particular local area network. On the upload stream, however, cable and DSL are closely matched for speed. DSL and cable internet providers often implement so-called speed caps that may limit the bandwidth of their services. High availability. They provide high bandwidth to low cost. No new software is required while using cable internet access. Always on connectivity. No reconstruction of the existing cable system is required. Limitations of the cable internet access are: traffic congestion on the internet. As cable modem is a shared network, so cable modem services can slow down significantly if the number of subscribers in your neighborhood is more which are accessing the internet simultaneously. Higher security risk than the dial-up connection, as it is a shared connection, therefore there is more security risk in case of cable internet access in comparison to the dial-up connection. However, cable service providers generally provide cable modems with security features in the hardware. And third limitation of cable internet is that it is usually tied with cable TV subscription. Next technology is leased line connectivity. This diagram shows how the internet service provider is connected to its subscribers through the leased line. It is used to provide point to point dedicated network connectivity. An internet leased line is usually a dedicated